Yeah, honest students, is my voice is loud and clear? Okay, so let's start the session. So the main part of Gen AI and Agentic AI course, this is the main one which we are entering now from today. That is related to text data, right? So in today's class, we are moving on to the text data, and first we'll start with the basic, and directly we'll move on to the next one. Okay, so working on the text data. Okay. So first we have worked on the earlier, the structured data. Okay. And in the structured data, we have executed the ANN. ANN was executed. And this structured data is non-sequential. It is not a sequential order data set. It is a non-sequential data. Non-sequential structured data, we have used the ANN model in the AI, within the AI. And next we have worked with the images. For the images, we have used the two types of projects are there within the images. And the first type of project is related to image classification. What are the image classification? And for that image classification, we have used the CNN. And second one is computer vision. And object detection. Object detection is the project. And for this particular project, we have completed the next one is called as CV. Okay, CV. Now we are moving on to the non-sequential text data. Non-sequential. Here, sequential order is not important. The non-sequential text data is available, and sequential text data is also available. Two things are available. So here, sequential text data and sequential structured data. Sequential text data and sequential structured data. Two things are there. Now, so these are the which we are going to cover now, one by one. Now, first, in the next 2 days, first I will cover the non-sequential text data. Today and tomorrow, we are going to try to complete the non-sequential text data. If it extends also slightly, third day. Okay. First, we'll complete the non-sequential text data. In the non-sequential text data, two types of projects are there. One is called as text classification project, and the second one is called as text clustering project. So two types of projects are available within the non-sequential text data. So we are going to work with these two types of projects within the non-sequential. As we know, non-sequential means the order is not important. The order of the words are not important or anything. So here it is going to work in a different way. Whereas coming to the sequential order structured data, structured means again CSV file or Excel file or something. Here we are going to work on the model called as LSTM. Here we have to first learn what is meant by RNN and LSTM. Then only, once we understand RNN and LSTM only, RNN and LSTM. First, we have to understand this. After understanding this only, then we can move on to this one. Here, we are having the Gen AI. Okay, sequential order. Here, sequential order of the text data only is called as Gen AI project. Now, this in the Gen AI also, we are having the different types. Different types of things are there that we are going to discuss in the order. Now, so in the text classification and text clustering projects, first let us complete this one, and from here we'll complete this one, and from here we'll move on to this one. But everything are the text only. Just in one class we are going to complete this one, just to understand what is meant by sequential and what is the importance of sequential, because this is going to play the base for this model. Okay, so with this Gen AI will start only by understanding these models. Without understanding these models, we cannot work. So, right now, coming to this non-sequential text data. So how to handle with the non-sequential text data, where the text data is not important. So non-sequential text data, how we are going to work is this one only we call it as NLP, natural language processing. So now here in today's class, we are going to start with the NLP. Okay, NLP means nothing but natural language processing. Natural language processing. What is meant by natural language processing means whatever we are speaking or whatever we are typing, it may consist of grammar mistakes, but still the machine has to understand the given question and it has to give the proper reply. Okay, or it has to give the correct answer. Reply means in terms of output. What are the output is there, that we call it as reply. Now, here natural language, what is meant by natural language means whatever the human speaks naturally, this one has to be processed. Okay, so in the English language, everyone are using the English language. Some of them may have the proper, perfect English language, that grammar they will follow perfectly. Some people may not follow the English language properly. Okay, they speak with the grammar mistakes, some grammatical mistakes. Okay, some grammar mistakes will be there. So wherever the future sentence is there, instead of using the future verb, they may use present or past verb or something, right? So in sometimes I will also do the multiple mistakes of English grammar, right? While speaking, I'm not going to speak the perfect English grammar, right? Now, still, whatever I'm not able to speak the perfect English grammar also, still the students are able to understand the complete one. Whatever I'm speaking and whatever I'm explaining and everything, they are trying to understand. That only whatever your brain now it is doing, it is only called as natural language processing. So here, naturally, whatever we are trying to speak, right? Speak or type or whatever it is, text data, natural text data that has to be processed. Okay. Now, as I've told you, this processing, okay, what are the processing is there? Here also, max will be applied. So in order to apply the max, automatically we require the numbers. So nothing can be done in terms of without numbers. Okay. Now, so here, as I've told you, two types of projects are there. One is called as test classification project. As earlier I told you, test classification project and test clustering project. As we are having the two types of projects are available. So first we are going to start with the test classification project. Now let us understand how this test classification project works. And based on that, we can move on to the further. Now, so here, okay, I'm going to explain for you the test classification project, how it is going to work. Now, as test classification project, the how will it be there means we'll have the input and we'll also have the output. Sir, this is a structured data or unstructured data means I'll show you with a small example here. Okay, now everyone can see here two columns are there. This is column number 1 and this is column number 2. First, this is a notepad file here. Can you see what is the type of file? Here remaining files are like a text document or CSV or Microsoft Excel or something. But this type of file is called as flat file. These files are called as flat files. Now, here first I'm going to load the flat file. What are the flat file is there? First I'm trying to load the flat file. So how to load the flat file means here we are going to use the the file name. What are the file name is there? First, I'm going to import the pandas as PD and read underscore CSV. And here I'm going to give the file name. What are the file name is there? I'm just providing the file name. But it is going to throw the error because it is not separated. because the data was not separated in the two columns. So now how I'm going to separate the data in the two columns means here I'm going to consider this flat file. Within this flat file, whatever I'm having, in this tab space is there here. Can you see the tab space? So the before to the tab, whatever the one is there, it has to be considered in one column. After the tab has to be considered in the second column. So before to tab, whatever the before to tab is there, it has to be considered in the first column. Okay. Now, so here I'm going to give the separator SEP. It is equal to /T. /T means nothing but tab. So before to the tab, consider as one column. After the tab, whatever you are having, consider as one column. So automatically the first record is going into the heading. So no need to consider the heading as the first record. So instead of considering the first record as the heading, here I am going to provide the names. In the pd.read_excel, the keyword is different. In the pd.read_csv, the keyword is different. The keyword we are going to write for the column names is names. In the names, I'm going to write here left this column name. What is the column name is class or output. Right side, I'm going to give the column name as message. This is the message. So now I'm having the two columns. One is class. Class means where it consists of classes, I mean categories, because it is a classification project, right? Classification project means it consists of classes, either positive class or negative class. Some classes will be there, right? And at the same time, second column is going to be the message, right? So here, sir, this is a similar kind of structured data, right? This is considered as what type of column? Discrete variable. Discrete categorical. Already you know what is discrete categorical. In the classification project we have seen. Now coming to this one, this is considered as text data. Now question is, why we have to consider this one only as the text data? Why we cannot consider this one also as a categorical column? Because it is a structured data. In the structured data, which of the table consists of text columns, they are all called as categorical, which consist of numeric. They are called as either continuous or count variable, right? So obviously this one also can be considered as a categorical variable now. Why we cannot consider this one as a categorical variable? Means because here you are not having the categories like this. Each message is a different one. Okay, if you consider the unique values, how many unique values will be there for this particular column? If you observe the number of unique values of this particular column, that is message column. What are the message column is there? Here I'm going to consider the df of message dot n unique. N unique means number of unique values. If I ask the number of unique values, you can see here total 5,169 unique values are there. Okay, that many categories will not be there, right? So here, and that too, it is category means will have the single word or maximum two words like positive, very positive, like that. Limited number of categories will be there. 1, 2 categories, 3 categories, 4 categories, 10 categories. Limited number will be there. Yeah, out of 5,572 records, 5,169 categories only will not be there. If that many categories are available in a single data set, means out of 5,572, if these many categories are there in the real structured data, means then we have to drop the column. Means in that case, we have to drop this column. Right? Now, first, let me explain for you the business problem. What is the business problem? Means we have to classify for the test classification project. What are the test classification project is that we have to classify whether the given input, we have to classify whether the given input belongs to which class of output. Whether the given input belongs to which class of output. So here we have to classify this. whether the given input belongs to which class of the output. Is the point is clear? Everyone. So here the input example for this is example. What are the real-time applications? Examples are nothing but real-time applications where we are going to use the real-time applications means, for example, whether the review, what are the review was given to us, whether the review is positive review or negative review, or whether it is a neutral review, negative or neutral. Total 3 types of reviews will be there. Okay, positive, negative, or neutral. Sir, that we can read the sentence and we only can say no, sir. For that, again, this one is required. Miss, see, for example, total 10,000 reviews are available. Are you going to read each and every review and you are going to say this is a positive, this is negative, this is positive, this is negative? Are you going to say like this? Are we going to predict in this way? No, right? So just to predict for the future data, to predict on the future data whether the given review is positive review or negative reviews. Nowadays, we know in every whatever we are doing on the social media, for every small things, reviews are common. Right? Even if you are booking some kind of Rapido or Swiggy or Zomato or hotel or train or bus or something, whatever you are going to do, whatever you are trying to do, everything nowadays we require the reviews. Right? So reviews is nowadays one of the most important, like in the Amazon website or Flipkart or any website, if you are doing the purchase, shopping or anything, reviews are going to be the crucial. And one more application is, for example, the given mail. I have sent you a mail. Now that mail will go to for spam or ham. Ham means nothing but inbox. If I send one mail to you, whether are you going to receive this mail in the spam mail or in the inbox mail? Okay, you are going to reach how that Google is classifying spam mails. Open your mail ID. In the mail, you'll have the some spam mails automatically. How the Google has sent automatically them into the spam. And what is the purpose of doing that one? Like that, if the Google separates the spam mails like that, what is the use the Google is going to get? Is the points are clear? So now these are all the applications. So now in the inbox, for example, if I send a mail, something like this, guys, tomorrow we will do a project, a end-to-end project here in test classification. Something I have sent like this to your mail. Okay, in test classification. I have sent something like this to your mail. Now, what are the mail I have sent, whether it goes to the inbox or spam? How? Okay, sir, it goes to the inbox. How? How the in the backend, what is the code? Simply it is sending a. Then in the same way, you have won a lottery. Okay, you have won a lottery of 1 crore. You have won a lottery of 1 crore. This will also go into the spam normal mailer. If I send, right? So how it is processing that? So how this everything are working, that we are going to understand. Everyone is clear till now? Online students? Right? Now, so to work with the test classification project, and we have to predict for the future means, first we require the past data. Anything has to be done on the training. Okay, this is a kind of classification project. As we know, classification project in the structured data, how we are having, similarly here also. So same kind of steps will be involved in the structured data classification project. What are the steps are there? Here also similar kind of steps will be involved, right? There will be no much difference in the steps. Now, coming back. Now, as first I'm going to write the steps involved in test classification project. What are the steps involved in the test classification project? Like similar kind of general classification project, what are the steps is there? In the first step is business problem understanding, common. Second, you are going to load the data, common. There and here also you are going to do the same, load the data. After loading the data, you are going to do the data exploration. Means understand the each and every column, internal values along with the column names. That is data understanding, common. After loading the data, you have to do this, right? After doing this one, next one is where you are going to do the data cleaning or data pre-processing. If you remember what type of data pre-processing we have done in the structured data of classification project, guys, everyone, structured data of classification project. What type of data pre-processing we have done for the structured data? I'm asking for the structured data. Yes, cleaning and transformation. So that whatever the overall we call it as cleaning the missing values or cleaning the outliers or cleaning the wrong data, everything comes under part of data cleaning. At the same time, transforming the data from, and that is encoding or scaling or anything comes under data transformation. Means you are going to transform the data, right? These are the two things which we have done in the structured data, right? So this that for example encoding, it might be include the encoding or scaling. Okay, that is the part of transformation. Whereas dropping the duplicates or cleaning the missing values, replacing the wrong data, all these things. Okay, right? Now, so with now here also we are going to do the similar kind of data cleaning, but it is not the like treating the missing values or not treating the outliers or something. Here also we are having the data cleaning. Here also we are having the data pre-processing. That data cleaning, whatever we are having is called as remove the punctuation marks. Here we are going to remove the punctuation marks. First one is. So this data cleaning, whatever we call it as text cleaning. Okay. Structured data, we call it as data cleaning. For text data, we call it as text cleaning. Text data cleaning or text cleaning simply. Right? First step is remove the punctuation marks. We are going to remove the punctuation marks. Second one is we are going to remove the, after the punctuation marks, we are going to remove the stop words. Stop words means unimportant words. I will tell you one by one what is stop words and how to remove everything. I will tell you one by one. Right? And third one is either we have to apply the stemming or lemmatization. Out of these three, one of them has to be done for each word. So for each word you have to do means first you have to do the tokenization. Tokenization means what are the sentence is there? The sentence has to be converted to tokens. Tokenization. So first you have to convert the sentence to tokenized tokens, that is words, And for each word, you have to remove these things, right? At the same time, data transformation, which we call it as vectorization. Vectorization means convert each word to a vector. So here we are going to do the vectorization. So this is the overall which we are going to have in the step 3. Within the step 3 of text to data, first we are going to do the tokenization, followed by cleaning, followed by vectorization. Then finally, we are going to apply the model. So to apply the model, as we know, we have to split the data into train test split and fit on X train, Y train. Similarly, model.predict on X train, model.predict on Y train, and we are going to do the evaluation. So modeling plus evaluation. Same. So what are we are this in between? What are we are going to do now? This is going to change. The data pre-processing is going to change. So we are going to focus on this one in the today's class. I'll explain each and every step clearly. What is meant by tokenization and what is data cleaning and everything with a small example. So, the same with respect to we are going to load the large data like example of Gmail classification. What are the Gmail mail classification is there? Na? Gmail, Google. So what are the mail classification is there? Let us do one project on that. One real-time application project, right? Now, so here, what are the data pre-processing we are having? So first one is tokenization, followed by data cleaning, and all these steps, one by one, one by one. What are the steps are there? Let us implement each and every step. One minute. Done. So first, we are going to start with this. That is, we are going to work on the library called as NLTK. The library name is called as NLTK. The full form of NLTK is nothing but Natural Language Toolkit. Okay, this is the library name, Natural Language Toolkit. NLTK, right? So first we are going to import this NLTK, and after importing this one, whoever has installed Anaconda, automatically default NLTK will be available. If it is not available, use the pip install NLTK. If it is not available, by default it will be available. Only thing is here nltk.download. You have to click on the nltk.download so that it will be downloaded the latest packages. So for many students, for every student in this class, whoever has using the first time NLTK library, obviously when you are using the nltk.download, okay, here it is going to open in a separate tab. Just the moment we click on the nltk.download. Just a minute. Yes. Here you are going to get like this. This is the tab which you are going to get. So here, what are the tab you have got? NLTK.download. Here, few of them have got installed and few of them are outdated or partial installed or anything will be there. Just you have to click on the download. And once you click on the download, it will download the latest packages and it will install automatically. And everything has to be converted to green color. Okay. So it is going to download the remaining things one by one, one by one. It will only download automatically. So obviously we require the internet connection to download the package. We require the internet. And once it is downloaded, it will only install. Okay. Yeah, after importing the NLTK. Yes. First you have to import the NLTK, then after that only we can do this. Okay, let me re-execute. Why these are not got updated? 1 minute. Guys, others, anyone trying in the laptop miss, could you please confirm? Are you going to get the same issue or everything got installed? Generally, it will take time and it get installed. Others, could you please confirm? Anyone trying? Yeah, I can see one student. Yeah, it is downloading. And second, Jahanavi, it is done, sir. Miss, everything are updated, right? Everything are converted to green color for you, right? Jahanavi. Okay. Mm, in my case, why it is showing like this? Okay, guys, let me cross check. Generally, for you case, in your case, everything will be converted to green color. In my case, whatever have problem is there, just I'm going to cross check once the class was completed. Let us now go into the next one. So here, first I'm going to explain for you the tokenization. As in the data pre-processing, whatever we required is first one is tokenization. Now, what is meant by tokenization means breaking into parts. The meaning of tokenization is breaking into parts. So, what parts? For example, here I'm considering this is an example where, as we know, it is a string. Okay, he is a good boy and she is a good girl. Boy and girl are good. Let's assume this is one sentence. It's in the string. As we know, the multiple sentences can be either in the single line string or multi-line string. If it is in the multi-line string, triple quotes open, triple quotes close. If it is in the single line string, single quote open, single quote close. Right? Now here, in this, I'm going to do the sentence tokenization. The first one, I'm going to use the sentence tokenization. What is meant by tokenization? I told you, tokenization means breaking into parts. Sentence tokenization means breaking into the sentences. So here I'm having the total three sentences. He is a good boy. She is a good girl. Boy, girl are good. So just it is going to break into the three different sentences. Sent.tokenize. Sent underscore tokenize is nothing but here what are the function is there? Sentence tokenization where it is going to break into the sentences. This from here to here is one sentence. This is second sentence and this is third sentence. Three sentences are stored in the list, within a list. Second, word tokenization. What is meant by word tokenization means break into words. Sentence tokenization means break into sentences. Word tokenization means break into the words. So here, I am going to break into the words. What are the words are there? Here, NLTK dot word tokenize. Word tokenize means it is going to break into the words. So first word is he, second word is, a, good, boy. If you remember the string dot split in the starting initial classes when we have discussed the string dot split. String dot split means it has given the output. What are the string dot? Okay. What are the split is there? Na? Split is going to give the output in the output. What are the split is there? The split you are going to get as the output as list of things. If you remember in the Shiva space, Rama space, Krishna, when I apply this one, and if I apply the S is equal to and S dot split, automatically I'm going to get the list of words, right? List of words. Similarly, here also in the sentence tokenize and word tokenize, in the sentence tokenize, it is going to divide into the sentences. As in the backend, we know that wherever the full stop is there, that sentence was completed. After the full stop, new sentence will stop as per the English grammar, right? So it is going to identify that, and based on that, it is going to separate the data. That's it. Okay. Now, so here a sentence was completed at the full stop. So this is considered as one sentence from here to here. And the second sentence starts from here to here. If any sentence starts with the space, after the full stop, sometimes we'll have the space now. If any sentence starts with the space, it will automatically apply the strip. And in the starting or ending, any spaces are there, it will remove. So just it is applying the split function only. Literally, it is applying the split function based on the dot. Wherever the full stop is there, we'll have the one sentence. That one sentence was completed, right? And sir, directly we can apply the split only now. Miss, when we apply the split here in the second sentence, space also will be added. Here the space was removed. Means it automatically applied the strip. A split function along with the strip function. Both are applied. Okay, Vamsi, is your question is clear? And word tokenize, as we know, word tokenize means every word, English one word to another word. How we are going to separate two words means based on the space. So here it is getting splitted on the space. What are the spaces there? Based on that, it is just splitting the data. Everyone is clear? So tokenization means splitting the data into parts. Here Bharat says that I got the same error. I just clicked download by selecting all of them. Okay. As Bharat has saying that selecting all of them. Okay. Let me select all of them. and click on the download. Yeah. So earlier I have cited singular. Then maybe while selecting this, it has. Mhm. No. Now as I'm getting the same problem. Okay. Anyways, let me cross check Bharat. It's okay. I'll cross check myself. Okay. Done. Now that's not a problem. If required, we can re-import one more time. Okay. Now, so here, this is the stop words. What are the, word tokenization. Now, in the word tokenization, if you observe here, we are having the different words are available. In that words, dot also available as the one of the word. But we know dot is not a word. It is not a word. It is not used to classify. For example, SRK explained clearly. Positive sentence or negative sentence? SRK explained clearly. Positive or negative? Means we are going to say it is as a positive, right? Now, SRK not explained clearly. What are the we are having? Not explained clearly. Positive or negative now. Means this is positive and this is negative. So how we have identified this as a negative means by the word called as not. Now, is there any connection? If I write instead of caps lock XRK here, this will be modified into anything specially? Or if I write here dot, whether it will change? Or if I go with the cap explained, this one in the caps lock, explained. If I write like that, whether it is going to change? No, right? So here the positive or negative is not depend on the lowercase or uppercase or whether what type of grammar you have used or comma you have used or for example I have completed the sentence like this SRK not explained clearly with semicolon or at the rate of I have written and at the end in the starting I have written like this. Now this sentence will be considered as negative sentence or positive sentence means at the rate of is not having any importance now, right? So when it is not having any importance for predicting the output belongs to which category. For test classification project, it is not important. Sir, but for example, some other projects we are going to do in the chat GPT, for example, if you type one sentence, it is going to give the output in that sentence as plus stop also important. Now, means that is different project now. Application is completely different. So for this particular type of project, here we don't require the punctuation marks. So since we don't require the punctuation marks and it is not having any impact on the output variable, if your punctuation mark is there also, not there also, output will remain same. So the punctuation mark is not having any importance on the output variable. So that is the reason we are going to remove the punctuation marks. Is the point is clear, everyone? Now, after removing the punctuation marks, balance you will have the words. Simple words are available. Some words are available. Is the point is clear, everyone? Yes or no? So test classification project, the prediction of the output, whether it is a positive class or negative class, what are the category we are going to try to predict, it will be dependent on the what words are there. It will not be dependent on the this. For example, instead of SRK not explained clearly, okay, instead of this one, not explained clearly, I'm writing like this, not explained clearly SRK. Now I have brought the last word, this first word into the last position. Now, whether it is positive sentence or negative sentence, positive or negative, guys, still it is a negative only. Now, whether if I write the SRK word in the starting or if I write in the ending, any difference is there? Or if I write instead of here, if I write here SRK, not explained SRK clearly, if I write like this, is there anything difference is there? So here order of the words are important or order of the words are not important. In this example, only, purely for this example. Okay. So here the order of the words are not important. Point is clear? And this classification project, what are the classification project is there? Now, okay, if I give one sentence to you, any English sentence, single sentence or multiple sentence, this is overall single review, one review only. That review consists of single sentence, that review consists of multiple sentence, but one review. This one review, whether it is a positive review or negative review, how you are going to decide? Manually. Tell me manually. Forget about the computer and program or anything. If you are reading manually by English sentence, when you are reading, how you are going to classify? How you are going to classify? Right? So what are the words are there? By saying the words, and in that words, for example, some bad, not good, okay, worst, something we find the some negative words now. Based on that, we are going to say that it is a negative. When we find some kind of post like good, awesome, nice, based on these words, we are going to say that it is a positive review, right? So some words will be there. Positive words are there, negative words are there. Who told you these are called as positive words? What are the positive words are there? Who told you the positive words? Who told you the negative words? If you try to recollect of yourself, okay, in our childhood, whenever we started the English classes, at the time they told that this is positive word, this is the negative word, or something, something, and we got trained on that, right? Similarly, here also the same, right? Same way. Okay, here also from the same way, just we got trained. So some words. So now the same way, I'm going to give to the machine. Okay, now just you can tell me any some sentences, guys. As per your choice, you only can tell me the some sentences like reviews. Assume some reviews. Could everyone please could you write the review? Might be one sentence or two sentence. Choice is yours. Everyone, please. Right now. Online students, could you write review? Or please write the review about our course only. Our course or about my explanation or something. Write the review right now as an example so that I will explain the same thing. Everyone, please. Okay. One, two, three. Done. Done. Still. Still, guys. Could you add more? Some additional students are there, right? Guys, please type. Okay. Next. Next. I'm sorry. Yeah. Jahanavi. Done, guys. Uh, yeah. Sufficient now. Done. Okay. Right. And yes. One. Just okay. Done. Sufficient. Now, based on this, let us see. Okay, let us understand these things only. What are the live data you have provided for me? Let's understand this one. And based on this, how the machine will classify for the future data, understand. We will understand by considering these examples. Right? Done. Hmm. I'm copying the chat also. 1 minute. Shweta. Okay. I think I have copied multiple times. Huh? Oh, okay. Done. Okay, okay, done. Now we are having something like this, guys. In this, some of the related to training is there. At the same time, something movie like Dharmendra has shared about the movie and match or something, right? Now, first, let us start with this. It is a positive or negative. This is past data. I require the past data. To work on the future data, first I have to train with the past data. Now, for the past data, I'm having the input. This is my input. At the same time, I require the output also. The output is nothing but called as label. What are the label is there? I'm going to have the label. Okay. Now, so input is there, output. Now this one, let's start with this one where we are having the positive and next this is kind of negative, right? And age is GD is there. Okay. So assume here, though it is GD is basically for us, it is good. Okay. But how the machine will understand, I'll show you. This is all important. Okay. Shanti has given some new word for us here. And that type of words only is important for us to understand, basically. Right? Training is this one. And here that style is slow. Here we are having, let us take this one as neutral, a category of neutral category. And today's India New Zealand match was interesting. And again, let us take this one as positive. And good for this one. This is also again positive. And please provide the everyday's notes. So I'm considering this one as neutral. Assume. Okay. Code daily. Again, I'm going to consider this one also as neutral. Let's take an example like this. Okay. Now, here I'm having the some of the positive reviews are there. One negative is there. That too, Chiru movie. It is not related to training, but neutral is some neutral is there and positives are there. Let's take it like this. Now in this sentences, okay, this is the past data. Now in this past data, whatever we are having here, from this past data, and here these are the words. Now, which words, for example, your is there in this entire overall, in the entire overall, how many times your was repeated? How many times your is there, guys, in this entire one? In this entire one, how many times your is there? Only one time. And that too, that one time was in the pause two only. That too, it is in the pause two only, right? Right? Now, for example, let's take Dilip has given here one sentence. Okay, something. Now I want to predict for this. What other Dilip has given me the sentence? This is my future data. For this future data, I have to predict whether it is a positive or negative or something. Okay, now let me remove this. Just I'm writing up to here only for understanding purpose, easy understanding purpose, guys. Now we are enjoying with your teaching or something. Now in this, first I will start with the V. In the V, in the overall entire train data, from here to here, it is train data, that is past. What are the past data is there? So in this data, how many times V was repeated? Tell me. How many times V was repeated? WE. In this entire one, how many times WE is there? How many times? No, it is not there, right? So we will ignore the V. Since it is not there, we'll ignore. Next, R. How many times R is there in this entire? R. ARE. That might be come in the positive, that might be in the negative, or that might be in the neutral, anywhere. But how many times? So it is also not there. Just let us ignore. Enjoying. Enjoying word. How many times was repeated? Right? So whichever the word got repeated, for example, this is also not there. Here, with your teaching, okay, with word, your teaching, and at the same time learning. Like this, for each word, every word, okay, first it will observe within the train data. What are the V is there? In the train data, within the positives, in the positives, how many times it was repeated? In the negatives, how many times repeated? In the neutral, how many times repeated? For example, out of these three, if V was repeated more number of times in the positive, then it will be considered as positive, single word. Second, R, it will come to the R. R was repeated in the more, in which one it was repeated more number of times. For example, R was repeated more number of times in the negative, then it will be considered as negative. Next, enjoying. Enjoying word, how many times it was repeated in the positive sentences, I mean positive reviews. How many times it was repeated in the negative one? How many times it was repeated within the neutral one? For example, 10 times it was repeated in the positives. Positive sentences 10 times. Negative one is just 2 times. Neutral one. Negative is 0. Now, out of which one is the highest? Out of these three, which one is the highest means positive. So, this one will be considered as positive. And similarly, this one. Similarly, this one. Similarly, this one. Similarly, this one. Like that, each and every word. How many words are there? Each and every word. First, we are going to consider positive, negative, positive, negative, positive, negative. How many positives are there? How many negatives are there? Okay. So here we are going to have the positives and negatives. Now in the given sentence, for example, 1, 2, 3, 4, 5, 6, 7, 8. Total 8 words are there. In the 8 words, 5 words are related to positive. Okay, more number of times it was repeated in the positive in the train data. Within the train data, it was repeated. Then 5 words are related to positive out of 8 words. Within the 8 words, 5 are positive and 3 negative words are there. Then overall this whatever the sentence is there, this will be considered as positive sentence. For example, 5 negative words are there, 3 positive words are there. Then it will be considered as negative sentence. And 4 of them are positives and 4 of them are negatives are there, miss. Then in that case, it is going to consider as neutral sentence. So it is going to work in that way. So based on your past data. So here in your, as I've told you as earlier one example, what is that example I have told you, miss? Male classification. What are the male classification is there? So in this male classification, already in your inbox, in your inbox, let's take some 2000 mails are there. In your inbox, some 2000 mails are there. Whether you read, may not read, but 2000 mails are already available in the inbox. Within the inbox, 2000 mails are there, right? Then if it is not repeated, then which category follows, miss? It will be ignored. That particular word will be ignored. Ritish. Right? Whichever the words first time it is having, that words will be ignored. Next time onwards, it is also used in the part of training. Next, coming to the spam. Assume spam mails we are having some around 200 mails are there. Okay, 200 mails. These 2000 mails and 200 mails, 2000 or 1000 mails. Okay, some 1000 mails and 200 mails. This is already in your mail account. Whatever your account is there, in your account already these mails are already available. Already they are available. Now, since they are already available, I'm going to send the new mail for you. When I'm going to send this new mail, in this mail, automatically words will be there. The mail consists of words. Okay, sir, along with the words, for example, image also is there, sir. That is attachments now. That comes under attachments. PDFs or what are the images or something you are sending now. Everything comes under attachments. I'm not focusing on the attachment, the mail content. What are you are going to write in the subject line, or you are going to write in the message line, in the message part. Whatever we are going to write now, that one. So here automatically it consists of words. The new mail, whatever we are having, consists of words. Okay, so what are the new mail you are having? It consists of words. And what are the words it is consisting of? In these words, take the each and every word. Every word. Now that every word, out of the word, for example, let us take the SRK word. That word might be available in the spam mail. That word might be available in the inbox mail. For example, in the inbox, SRK word was given total out of 1000. Approximately, let us take 50 mails are there with the SRK word. 50 mails within the inbox. Within the spam, the same SRK word is there for 100 times. 100 mails consist of this one. Now we are going to calculate the probability. Probability means percentage. That is nothing but 50 out of 1000, 100 out of 200. That is the one. Is the point is clear? Everyone understood? So here we have to calculate the percentage or weightage, how much weight it is having. So now 50 out of 1000 is having the more weight, or 100 out of 200 is having the more weight. More weight means more value. Which one is having the more value? Right? So here we have to observe that. Right? For example, here 300 mails are there. 300 mails consist of SRK. Though 300 mails are there, value wise which is highest? 100 or 300? Which is highest means inbox is highest. We should not see the value wise. We have to see the percentage wise. So 300 out of 1000, 100 only out of 200. 300 out of 1000 is 30%, whereas 100 out of 200 is 50%. So since it is having the more weight, So automatically SRK word will be considered as spam. Like that, how many words are there? Every word it will calculate for every word. So if I send one mail to you, in that for each word, it will calculate what is the probability. That we call it as probability means number of times it got repeated in the inbox and number of times it got repeated in within the spam. And it will observe that calculation. And from that, it is finally going to identify the given sentence is a positive one or a negative one. I mean, whether it is an inbox one or a spam one. In that way, it is going to send to you the inbox. If it is finally, the final output says that more number of words are related to inbox words, then automatically the new mail you are going to get in the inbox. Okay. Everyone is clear? I'm trying to explain in a simple way. The max I will explain in the detail. The concept name is called as NavBias. What are the probability we are going to discuss? The probabilities and everything is called as NavBias. Now, but sir, for example, in this, let us take total the new mail. What are the new mail you have got? In this new mail, assume total 20 words are there. 20 or 25 words are there. Out of 25 words, 22 words we have identified earlier. But 3 are new words are there. Those are not available. Either in this or in this it is not available. Then what happens? Means it is going to ignore those 3 words as of now. For this new mail, those 3 words will be ignored. And for the remaining 22 words only, it will calculate. Right? Now, again, you are going to receive the new mail. Now. Once this is completed, new mail you are going to receive, right? Assume this is first mail which you have received, the new future mail. In this 25 words are there, out of 22 words are available already. And from this 22 words you have finalized, it is a positive one. Positive one means inbox. Since 3 words are not available, you have ignored. Okay. These 3 words you have ignored, and based on the 22 words, you have classified this one as inbox. Now, second mail you are going to receive next day or same day or something. Okay, second mail. Now, when you are going to receive the second mail, the first mail, whatever you have already classified into the inbox, now your inbox will have the total 1001. Now, these 3 words are also included there, right? In the inbox now. Like that, the more amount of data it comes, automatically more amount of words will be integrated. Point is clear? Now for the future data, what are the next step? For example, after 10 days, what are the mail classification will be done in your mail? That will be decided on these 9 days mails also. For example, I have sent one mail from Naresh IT. You have selected that one as a spam. Next time in the future, whenever I send a mail, automatically it will be classified in the spam. Why? Because point is very simple. You have given my words as the spam words. So that one also will get trained. Point is clear? Yes or no? Everyone, could you please confirm? Next. Sir, I have one mail in spam. The words exist in spam. It will be 100% right or maybe incorrect. So here, it is not going to observe in that way. Just it will count. For example, you have told that good word only. For example, you have tried the good word. Good word, you have tried the label. The label you have given with the negative. Good in the another mail, it is also a negative. In the another mail, it is also negative. Now, for the future data, what is the good word? Answer is what? For the future data. Means negative only. Simple. Okay. For example, if you provide the wrong, for example, if you train the students in a wrong way, I have in the school, I have trained the students 1 plus 2 is equal to 4. If I train, what happens? Because they don't know what is the exact answer, I will train that 1 plus 2 is equal to 4. They will also not learn outside. Whatever the SRK has told in the class, they believe that and they will learn the 1 plus 2 is equal to 4. After 1 plus 2 is equal to 4, 1 plus 2 is equal to 4, they have trained. In the future, what happens? If you have given a wrong data for training, automatically accuracy also will be wrong only, right? For the future data prediction also will be wrong. So because it doesn't understand, okay, you have provided the wrong data, so this is not a correct one, please provide the right one. It will not ask like that. Whatever you have provided, based on that, it will work. That only we call it as data integrity. So now, as Morley is saying, sometimes in the spam mail, we'll click on that and we'll send it to the inbox. Sometimes, what are the mails we receive in the spam might be important, and we are going to send them into the inbox. Now, in that case, what happens? Automatically, these words, for example, as I've told you now earlier, SRK, for example, SRK word is there in the 200 mails. Okay, in this 200 mails, 100 mails consist of SRK. But what you have done? Here, 10 mails, what are the 10 mails which is having the SRK, you have sent into the inbox. Now, automatically what happens? Now here, SRK consists of in 90 mails. Here it is going to add that 310 mails. Simple. Is the point is clear? So once you send that one, automatically the counting will change. Morley, is that clear? Right? Done. Next. So here, guys, is that fine if I continue for additional half an hour or something? Online students, could you please confirm? Till 8, not a problem, na? Just give me 1 minute. Up to 8, done. Just give me 1 minute. Yeah, yeah, guys. Is that clear? Now, can you? Yeah, can I continue now? Uh, Dilip, for today's class, as I'm continuing from here, okay, since it's a lengthy topic, I cannot stop here. So that is the reason. And but at the same time, I can understand your situation. So what I'm going to do is today's what are the today's we are having now? Today's class recording. After the class was completed, today's class recording, I will upload. I will upload for every student in the Google Classroom. Okay, I will upload in the Google Classroom, right? Just for every student. Is that fine, Dharmendra? And only for today, guys. So some kinds of lengthy topics will be there, and that lengthy topics, if you stop in between, it will be a problem. Now it is fine, right? Dilip and Dharmendra. I think only two students has raised the concern. Niranjan, is that fine? Just the what are the concept we are discussing now? That concept will try to end. Otherwise, what happens means if it is continuing tomorrow, again Saturday we'll have the ML class. Again, it will be lead to the confusion. That is the reason. Right? Done. Thank you. Now, so what are this one is there, right? So now here we are going to have the example. Uh, yes. Before continuing, let me share the for 7:30 batch also. I have to tell the same information that I'm continuing your class. Yeah, just give me a minute. Okay. So now let us complete this one. Now, for this particular topic, yeah, online students, could you please confirm? Is that clear? Online students, please confirm. Is my voice is clear? Okay. So here we are having the point is probability. First, we have to understand the probability. So this test classification project works purely on the concept called as Naive-Bayes theorem. So to understand this Naive-Bayes theorem, we are going to understand the probability, the concept of probability. What is the concept of probability? Means probability meaning is, okay, chance of occurrence. Generally, what is the probability? We call it as chance of occurrence. Now, in this chance of occurrence, the probability is equal to number of, what are the number of items or number of records. Okay, number of records as per our requirement, as per our requirement. What are the number of records are there as per our requirements divided by total number of records. Okay, total number of records. We call it as probability. Number of records as per our requirements divided by, as per our requirement divided by total number of records, we call it as probability generally. Now, for example, if you take here as basic example for the probability, as we know, head and tails. Okay. So for example, what is the probability of head? What is the probability of head means here number of records or number of records or data points or values, anything, number of data points, records or values, number of values satisfy our requirement. Okay. So number of records satisfy our requirement divided by total number of values. So here total number of values are how many are there? Only two are there. Out of which how many is our requirement? Our requirement is whatever we are writing in the bracket. In the bracket we are going to write the requirement. Okay. The probability of requirement. So here we are going to write the sum requirement and the probability of, oh, sorry. 1 minute guys. So here the probability of requirement, that is probability of head, is equal to 1 by 2. Now similarly, what is the probability of tail? What is the probability of tail is equal to how many total values are there? Two values are there. In that, how many is your requirement? One only. So it is automatically 1 by 2. This is one example. Example number 1. Example number 2. For example, here I am writing A, C, E, F, A, E, C, C. Okay. Some I have written like this. Okay. Now in this, what is the probability of A? What is the probability of A? What is the probability of E? And what is the probability of F and C and everything? So first here, what are the unique values are there? What are the unique values? So unique values are here. What are the unique values we are having? Is one is A, second one is C, and third one is E, and fourth one is F. Total 4 unique values are there. So what is the probability of A? The first one is probability of A. What is the probability of A? Means total how many records are there or data points are there? Means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the 10, how many of them your requirement satisfied? 4 by 10. So that is the probability. And similarly, what is the probability of C? What is the probability of C? Means how many C's are there? 3 are there. So that is 3 by 10. Next, what is the probability of E. How many E's are there, miss? 2 are there. It is 2 by 10. And what is the probability? Probability of F means it is nothing but 1 is there, 1 by 10. Now, other than unique values, if you ask any other than unique value, if you ask anything new, for example, what is the probability of B? Then what is the probability of B is 0 by 10 because that is not available. Number of data points are 10. Total number of data points are 10. How many satisfy your requirement? What is your requirement is B. How many are there in the B miss? 0 are there. So automatically 0 by 10. So what is the minimum probability? Minimum probability value is going to be the minimum probability. What are the minimum probabilities there? The minimum probability is going to be 0. That is the minimum probability. Starting. Okay. For example, if that particular data point or that particular value, what are you identifying? If it is not available, the probability is 0. What is the maximum probability? Maximum probability is going to be 1. Automatically, the value is going to be 1. Means, example, let us take one more example like this. In this example, I am going to consider here the values are A, and A. Only A's are there. Now, what is the probability of A? What is the probability of A miss? It is going to be 4 by 4. So every value is A only. So 4 by 4. 4 by 4 is equal to 1. So simple point. So what are the probabilities there? The probability of A is 4 by 4. Is the point is clear? Which is equal to 1. If every value indicates same value, the probability is max. Now, can you get the negative value of probability miss? No. Because it is nothing but number of records. Number of means the value will be number of either 1, 2, 3, 4 or if the value is not available, 0 will be there. But negative value is not possible. Negative value is not possible in the numerator. Negative value is not possible in the denominator because both are count. Count cannot be negative. If it is not available, 0. Right? So negative is not possible. What is the minimum value then? 0. And what is the maximum value? 1. Sir, why 1, sir? For example, here, if I have one more A, then numerator will become the 5, no, sir. Obviously, numerator will become 5. Denominator also will become 5, right? Number of values down also increases now. So never the numerator can cross more than the denominator. Maximum here 5. How 6 will be only A? 6 or 7 or 8. Total only 5 are available. In this 5, maximum 5 out of 5 will be there or 0 out of 5 will be there. But it cannot cross more than the denominator. Na? So the maximum probability is equal to 1. This is one of the important question in the certifications. The range of probability lies between 0 to 1. Never it crosses more than 1. Never it goes less than the 0. It will be between. So for example, if I'm having here comma 1 B is there, then now total values are 6. What is the probability of A is 5 by 6? What is the probability of B is 1 by 6? 1 by 6. In this example, 1 by 6. Total 6 are there, right? Out of 6, how many A's are there? 5. How many B's are there? 1. Now, in the same way, the sum of the probability, take any example of your choice. What are the sum of the probabilities there? The sum of the probabilities is always equal to 1. For example, in the first example, what is the sum of the probabilities of each category? How many categories are there? You have to calculate for each and every category the probability and then you have to do the sum. That is 1 by 2 plus 1 by 2. What is the total? 1. If you take this example, in this example, that is second example, 4 by 10 plus 3 by 10 plus 2 by 10 plus 1 by 10. What is the total miss? 10 by 10. 10 by 10 miss 1. Now, if you take the example number 3, in this example, 5 by 6 plus 1 by 6. That is nothing but 6 by 6. Now, this is also 1. Right? So, in all these cases, what are the cases you are considering? In all these cases, the probability is going to be 1. The sum of the probability will be 1. Is the point is clear? Sir, for example, this is the data, sir. Example 2 only. But I have not calculated for the F. Only I have calculated for the 3 categories. Then the total is sum of the probability is 9 by 10. No. So here the point is sum of the probabilities of every category in the data. It is not limited category. If you are calculating only for two categories, the sum of the probability will not be equal to 1. How many categories are there? Sum of the probability of every category. How many categories are there? Every category you have to consider. Then only the sum is going to be 1. If you don't consider one of the category means, then automatically the sum is not going to be 1. So here, how many categories are there? Categories means nothing but unique values. Unique values, we call it as categories. So every category or every unique value, once we calculate the probability, and then if you do the total, then the total will be equal to 1. Is the point is clear? Everyone? Yes or no? Next. So here, the sum of the probabilities are equal to 1. Next, coming to the next one. So what are the probabilities? The minimum probability or maximum probability and sum of the probability. All these things we have calculated. Now you have understood what is meant by probability. Sir, the same probability in the numbers. For example, here it is categories. So we have completed. For example, I'm having the numbers like this 1, 2, 5, 9, 10, 11, 14. Every value will be 1, 1 only. Then in that case, how we are going to do sir? Probability means for numbers, the probability will never be calculated for this individual value. That is the difference between the continuous versus discrete variable. Discrete variables will be having the single values. Continuous variables, we are going to calculate the probability like this from starting to end. So we are going to give the some range. What is the probability of 1 to 10? What is the probability of greater than 10? Greater than 10 means what is the meaning? Literally greater than 10 is equal to probability of 10 to maximum. Greater than 10 means 10 to max. That is also range. What is the probability of less than 10? Less than 10 means the meaning is what is the probability of minimum value to 10? Minimum value to 10. That is the meaning. So whenever it is a continuous variable, for continuous variables, the probability will be calculated for the interval. For continuous variables, what are the continuous variables is there? Probability will be calculated for the interval, not for the individual value. For discrete variables, that is categorical variables or anything, the probability will be calculated for the individual value. The probability will be calculated for the individual value. For continuous variables, example for the continuous variables is this one. Like in this class, age of the students, 22, 24, 20, 23, 25, one more student 25, one more student 25, 24, 28, and 29, 22, 23, 24, something I'm having the ages. Now, what is the probability? So this is a continuous variable or a discrete variable first. Age is considered as continuous or discrete? Means continuous variable. So for continuous variable, what I have told you, probability should be calculated for the interval. If anyone asks you what is the probability of students having in your class more than 25? More than 25 means that is also interval only basically. How is that? Because 25 to max. What are the maximum value in the data set is that 25 to max. Basically it is interval. Okay. So how many students are there from 25 above? Divided by total number of students. First total how many are there? Here 3, 6, 9, 11. So total 11 are there. Out of 11, how many of them are satisfying 25 to maximum value? In my case, what is the maximum value first in the given data set? 29. So which is equal to probability of 25 to 29. So how many are there? 1, 2, 3, 4, 5, 6, 7. 7 people are there. 7 out of 11. That is a probability. So whenever you are calculating the probability for continuous variable, we have to calculate the probability based on the interval. continuous variables never considered as a single value. Okay, discrete variables only we have to consider as a single value. That is the difference between the continuous versus discrete, which I have told you in the initial classes of this. Right? Now, so what are we are having here? The continuous variable and discrete variable and everything. What are we are having? These values. Okay? Continuous and discrete and everything. So in this way, we are going to calculate the probability. Everyone is clear? Probability calculation for continuous, probability calculation for the individual values, that is discrete. Right? Now, particularly coming to our project, that is test classification project. In the test classification project, we are going to calculate for the discrete only. Ritish, it's 6. 1, 2, 3, 4, 5, 6. Okay, done. Only 6. Correct. Okay. If 6 are there means 1, 2, 3, 4 and 5. And this last one is 6. Total 6 are there. So now what are the 6 are there? 6 by 11. Right? Done. So probability will be calculated in this way for continuous variable. Probability will be calculated in this way for the individual value. Now let us see the probability calculation in the test classification project. This is the max which will be applied now. So as earlier I told you now, more number of values belongs to which category. So this is the max behind the test classification project. So test classification project works. Okay. So here Naive-Bayes theorem. I'm going to share you this PPT. Okay. So what are the course and what are the PPTs are there? I'll share the PPTs. Whatever I'm writing on the notepad only will not be shared, as everyone knows commonly. Right? Again, in the starting first class itself, I'm saying that, and some of the students, as earlier in the reviews, they have written that notes. See, notes in terms of coding part will be updated on time. Whenever the notes related to notepad only, I'm not updating. Okay, done. Right? Now coming to this. Okay, here the Naive-Bayes. What are the Naive-Bayes is there? Let's see the Naive-Bayes theorem. This is the max behind the, max or what are the concept behind the test classification project. Naive-Bayes is a classification technique which works based on the Bayes theorem. Here there is a concept called as Bayes. And for the Bayes theorem, Naive was added. These are the two different scientists. Naive is one person, Bayes is one person. They are scientist name. So generally for the max, we call it as scientist. For the statistics or something, we call it as statisticians. Right? Now these are the two persons. Now what these two persons has done is basically Bayes has done like this. What Bayes has done? So whenever you are having the two classes, 2 or 3 classes, 2 classes also same logic, 3 classes also same logic. Okay. So first calculate the probability of first class. What is the probability of the first class? Separately you calculate. And similarly you calculate the probability of second class separately. And which one is having the highest probability? Out of these two, one will have the highest probability. Na? Simply select that one. For example, first one has got, okay, let's take an example like this. Earlier I have told you, na, like SRK word was repeated these many number of times. Okay, so earlier we have discussed here as an example. Now, for example, what is the probability of example guys, probability of SRK within the inbox. So within the inbox only. So in the inbox total, how many mails are there? 1000 mails are there. Out of 1000 mails, how many consist of SRK? Because probability, I told you, number of records satisfy your requirement divided by total number of records. So what is the probability of SRK within the inbox means 300. 300 out of 1000. 300 out of 1000 is nothing but value is equal to 0.3. Similarly, probability of SRK. What is the probability of SRK within the spam? What is the probability of SRK within the spam means? As we have seen earlier in the example, 100 out of 200. What is the probability miss? 0.5. Now, Bay has told that calculate individually separately the probability for each class. Two classes are there means two classes, three classes are there means three classes. Like that, you calculate individually separately. After calculating individually, whichever is highest, that is the answer. That is the class it belongs to. Simply has told like this. Who? Bayes theorem is this one. But what Navi has told is, here two classes are there, okay. But these two classes, when you do the sum should be equal to what? 1. But here the sum is equal to 1, na? No, the sum is equal to 0.8. So only two classes are there. But the sum of probabilities, what are the sum is there? The sum is not getting equal to 0.8. So as per our condition earlier, whatever we have discussed, how many classes are there? Every class, the sum of the probability, if you combine, it has to be equal to 1. But it is not satisfying the requirement. So that is the reason what he has told is, divide every value, the probability of each class you got now, the 0.3 divide by total, 0.8. This one also you divide with the total, 0.5 divided by 0.8. Now automatically what is the sum? Now in this case, what is the sum? Sum is equal to 0.3 divided by 0.8 plus 0.5 divided by 0.8, which is numerator is equal to 0.8, 0.8 divided by 0.8. Automatically the sum will be equal to 1. Is the point is clear, guys? This is Bay. One is Bay, one is Navi. So what Bay has told? This one. What Navi has told is always divide with the total, so that the sum of the probability will always be equal to 1. But which class is the answer means this one only, because obviously this is going to be the highest now. 0.5 divided by 0.8 will be highest, or 0.3 divided by 0.8 will be highest. Obviously this only will be the highest. Answer is same only. What are the Bay answer and Navi's answer? Both are same only. But Bay has given the up to here. Instead of that, always the sum should be equal to 1. If you remember, now, if you remember the softmax activation function, anyone can remember what is softmax? For example, if you are having in the output layer, 3 classes are there. And if I apply for this output layer, softmax acts the activation function. How it is going to work, guys? Anyone? How the softmax will work? Activation function of softmax. Anyone can remember? Right? First applied for the multi-class, that is okay. After that, exactly. So here sigma wxi plus b will be calculated for this separately. Sigma wxi plus b will be calculated for this separately. Sigma wxi plus b will be calculated for this separately. Out of these three, whichever is highest, that is the answer. Whether it is class A, class B, class C. Out of three, which one has got the highest? That is the answer now. Same way. Basically, softmax function is nothing but Bayes theorem. Is the point is clear? Sir, in the mail, for example, not only inbox and spam, nowadays in the Google, we are also having the like primary, update, social, promotion, something we are having now. Then calculate what is the probability of SRK in the primary? Within the primary, what is the probability? What is the probability of SRK in primary? What is the probability of SRK in the update? What is the probability of SRK within the social? What is the probability of SRK in the promotion? What is the probability of SRK in the spam? Now, for everything separately, for in your mail, primary will be some mails will be there, na? Within the primary mails, for example, you are having the total primary mails are 2124. In that, how many SRK are there? 12 are there. Calculate. Within the update, total 100. In this, not even one SRK is there. 0. Like that, you calculate for each of them. The update mails are separate, primary mails are separate. For each category, separate mails, right? Within those mails, how many times this particular word was repeated? Understood or not? The logic. Yes or no? Everyone, please confirm. So even it is 2 classes, even it is 10 classes, even it is 20 classes also, for each class calculate the probability. That is only Bayes theorem. Now, sir, for example, there is sentence, sir. This is one word. SRK is a word. For example, I'm having the SRK is a AI trainer. This is the sentence. Now, this sentence, how we are going to calculate? Miss, very simple. First, you take the P of the what is the probability of SRK, okay, within the primary or inbox, within the inbox into probability of each word in the inbox, within the inbox into probability of AI within the inbox into probability of trainer in the inbox. So inbox mails, for example, total inbox mail will be some 1000 mails are there. In that 1000 mails, how many SRK are there? How many E's are there? How many AI are there? How many trainer are there? Sir, mails are 100, sir. But E's word in a given mail, E's word will not be one time now. Mail is 100. But for example, in the single mail only, I have got 10 E's. 10 E's. IS was repeated 10 times. Then here, that is the point. I'm asking within the total inbox, how many E's are there? First, you calculate. In the total inbox, first, how many E's are there? First, you calculate. And that in that inbox, then you tell me what is the probability. Point is clear? Everyone, understood or not? Yes or no? Right? Now, so for example, SRK is a AI trainer. This is in the inbox. SRK is AI trainer and SRK is data science trainer. So trainer word was SRK word was repeated again 2 times in the single mail only. In the single mail only, it was repeated 2 times. Okay, in the single mail, which is output is inbox. SRK is bad trainer. This is, for example, I mean, not inbox. I'm using the word positive or something. Okay, inbox only. And let us assume this was as a spam. Within the spam you have received. Assume. Let's take an example. For bad you not receive in the spam. Example I'm saying. Okay, basically it is a negative. Okay. But since I have written for this both, again I have to write here good. Okay. Instead of that, simply I'm writing the spam. Okay. Now let us assume like this. Now total E's. How many E's are there? 1, 2, 3. Including this 4. Total 4 are there. In that, how many of them are inbox? How many of them are spam? 3 of them are inbox. 3 out of 4 from the inbox. 1 out of 4 is from the spam. Point is clear? So the same word might be repeated multiple times also. Just you have to calculate total number of times. So now this is the NAV base. Now let's take with a small example. And along with this example, I will explain for the test classification also how the NAV base will work. So NAV base is basically working on the theorem called as Bayes theorem. Now in the Bayes theorem, let's assume here we are having the data like this. Based on the age of the person, based on what are the age and what are the savings, based on the age and savings, we have to classify whether the person has to retire or not to retire. Yes or no. Based on what criteria? Age and savings. Okay. So these people are not to retire. These are the records retire. Sir, what is this point, sir? Here value is there now. For example, here 24, savings is 10,000 or $10,000. So wherever the 24 comma 10,000, 1 point will come, right? Like that for every record, one point will come. Whether the person has to retire, yes or no. Yes means blue color, no means red color. This is just a representation. This entire data we are representing like this. Is the point is clear? Here, for example, one data point is there. 24 comma 10,000, 24 comma 10,000, one dot, we are going to keep one dot. And the dot is here Y. Y means what? Retire. Retire, I'm going to give one color. Retire color is nothing but blue color. Not to retire color is red color. Just two classes are there, two colors I'm adding. Understood, guys? Everyone. Right? So here we are having the data points in this way. Just I'm representing the data points here. Now everyone please make a note of Bayes theorem. Okay, this is only one of the important in the certifications or something. Okay, Bayes theorem. So what is Bayes theorem is? Everyone make a note of Bayes theorem. So the Bayes theorem, what are the Bayes theorem we are having? Is nothing but prior probability. The posterior probability, the concept is remains same. Don't worry. The words are new words. Posterior probability is equal to prior probability into likelihood. Posterior probability is equal to prior probability into likelihood. Right? So what is prior probability? What is likelihood? Let us understand each and everything. right? Now, so here prior probability, prior probability. What is meant by prior probability means before starting. Now, if you take here in the given data set, now total how many points are there? First tell me total number of points. What is the total number of points? 40 plus 20. 40 blue points, 20 red points. Total is 60 points. Total 60 data points. Data points means values. 60 values are there. Basically 60 records. Out of 60 records, how many classes we are having? Output variable consists of how many classes? 2 classes. What are the 2 classes? One is the person has to retire. Second one is the person has to not to retire. That is blue class and red class. Now, what is the probability of retire? Retire means nothing but blue. What is the probability of blue? Blue color. What is the probability of blue means how many data points of blue are there means 40 out of 60. How many of them are red is there? Means 20 out of 60. This we call it as prior probability. Okay, in the given data set, whatever the values we are having, they are called as prior probability. Now, for example, let's take an example like this. Here I have loaded one data set. Earlier I have shown you that mails and messages. I mean this one, right? Now, total how many records are there, guys? Total how many records? 5,572 records are there. Out of 5,572 records of data set, what are we have received? In this, first our output variable. What is our output variable? Class. In the class, total how many categories are there? First let us see. How many categories are there? Dot unique. Just I'm asking the dot unique. How many categories are there? Spam and ham. Only 2 categories are there. Now, what is the probability of spam? What is the probability of ham? Calculating these two only is called as prior probability. So, in the given data, first I am going to ask the df of class. What are the class column is there? Class dot value counts. Dot value counts. What is meant by value counts means total how many records of ham are there? Total how many records of spam are there? Now, can anyone tell me what is the prior probability now in this example? What is the prior probability of spam and what is the prior probability of ham? What is the prior probability, guys? Can you tell me calculation? Prior probability. Prior probability means here 2 classes they have given. I'm not predicting on the future word also. I'm not taking the sentence. I'm not predicting anything. Nothing I'm doing. Just 2 classes are there. In the given 2 classes, what is the number of records of each of them? So what is the probability of spam means 747 divided by 5572 is prior probability of spam for this example, for this data set. Similarly, probability of ham is equal to, what are the probability of ham is there? 4825 divided by 5572. Okay, so this is called as prior probabilities. Whatever we have calculated, they are called as prior probabilities, right? Now, what is likelihood then? Likelihood is for each word, how many word is there now? For each word, calculating the spam and ham separately like this is only called as likelihood. So, for example, in this example, I'm showing. Okay, so prior total 60 data points are there. Out of 60 data points, the red points are 20. 20 out of 60 is called as prior probability for red. 40 data points are prior probability for the blue. This is called as prior probability. Next, likelihood. For example, if I take one data point like this, and this is the area. Now, in this area, total how many red data points are there? 3 of them are there. Out of 20 red data points, 3 of them are close. Out of blue data points, 1 out of 40. For example, there is a new person here. Okay, Aishu. I will tell you with a simple example, guys. Here, this one also. Along with this simple, one more example is, for example, you want to purchase the some phone. Let's take like this. You want to purchase one mobile phone. Now, while purchasing the mobile phone, you are going to decide on yourself is one way. Some people will be there. They will not decide on themselves. They'll ask others, and based on the others' opinion, okay, they'll ask one or two or three or four members, and within their vicinity means their circle. Within their circle, they'll ask some people, hey, which phone is best. One person will say, "Array, this mobile is best and model is doing good." One more student will say one more, and one more person will say one more. So within the whatever he is having in this surrounding, more number of people has told this is the best now, so he will purchase that one. That we call it as likelihood. For example, around his surrounding, 5 people has told that, array, purchase the Samsung. 2 people has told Realme. 5 people has told that, or 6 people has told that Oppo. 1 person has told that Apple. Now, which one they are going to purchase? Point is clear. So for each of them, probability will be there, right? The people, how many people has told me to purchase the Samsung? How many people has asked me to purchase the Realme or Oppo or Apple or anything? So the each one, the probability, that is only called as likelihood. In this example, sir, how you have drawn the circle, don't ask that question. You can draw the big circle also. Point is, here the circle is not matter. Point is, in that given area, how many data points are from which category? For example, the red points are 3 are there, blue are 1 is there. Okay, but 3 out of 20 data points, 3 of them is in the nearby, 1 is outside. So now if you multiply both of them, the posterior probability is equal to prior probability into likelihood. That is 20 by 60 into 3 by 20. 20 by 60 is the prior probability, 3 by 20 is the likelihood. Now if you calculate, you are going to get the probability of 1 by 20. What is the probability of bloom is 1 by 60. Out of these two, which one is having the highest probability, guys? 1 by 20 or 1 by 60? 1 by 20 or 1 by 60? So 1 by 20 is having the high probability. Since the data point, it is having the higher, larger probability with the red. So automatically now the new data point, the person having this much of age and this much of saving, whether this person has to retire or not to retire, means not to retire, because close to him more number of people are not retiring now. When more number of people are not retiring, obviously what he will do? He will also not retire. Point is clear? This is from a basic example. I will explain with one more example also. What is that one more example is? As I have told you now, Navi. What is meant by Navi, miss? This is Bay. Bay has calculated the posterior. 1 by 20, 1 by 60. Now what Navi has done? Navi has told that 1 by 20, okay, but it has to be divided with the total. That is 1 by 20 plus 1 by 60. Similarly, this is for red. So according to Navi, the probability of red is equal to 1 by 20 divided by 1 by 20 plus 1 by 60. That is a combination of both of them. Probability of blue is equal to 1 by 60, whatever you have got, divided by total. Total is what? 1 by 20 plus 1 by 60. So that the sum should be equal to always 1. Point is clear? Understood or not? Yes or no? How many of you are not clear? Raise your hand so that I will explain. Clear means okay. Everyone is clear, right? So what Navi has told is just to divide with the overall total probabilities. Every probability you have to calculate. Extra you have to do. So how to, this one only, calculation is this. See, when you are going to do the additional bottom, I have got the probability of red and what is the probability of blue. Probability of blue is 0.25 and probability of red is 0.75. Now, if you combine the total, both of them, red and blue, what is the total? What is the total? Obviously, you are going to get the 1. Is the point is clear? So, Navi is nothing importance, mainly Bayes only. Navi is dividing with the each probability again. The total of the probability every time we have to divide. Okay. So if P1 divide by total, second person, P2 divide by total, P3 divide by total. Now if you combine all of them, P1 plus P2 plus P3 is nothing but T by T. That is total by total. Total by total always will be equal to 1 only. So there is nothing difference. Main point, what Bayes is only main point. Now let us take like this. Now let us come to the second example. Don't get unnecessarily confused with the multiple examples. Example 1 is data example is completed. Now let us try with the second example, which is relevant to text, which is relevant to us. Now this is our second example, example number 2. Now total 100 maize are there. Example number 2, guys. Don't get unnecessarily confused. Example 1 is completed. Now example 2 I am explaining. This example 2 is related to text. Sir, one example is sufficient for us. No need of second example, miss. That is your choice. In the example 2, total maize. What are the total maize are there? Total maize are 100. Total only 100 are there. In my, that is my inbox. In the inbox along with the spam. Now inbox consists of, that inbox is nothing but ham. My inbox maize are total 72. My inbox maize are 72. My spam maize are 28. Total spam maize are 28. Now, can you tell me what is the prior probability of inbox and prior probability of ham and prior probability of spam? Everyone? What is prior probability of ham? Prior probability. What is the prior probability? Inside that, how many what words are there? Just ignore. Total number of maize only 100. In that, 78 of them are, 72 of them are inbox or ham and 20 of them are spam. Now tell me what is the prior probability of ham? Everyone. Right? 72 out of 100. Now prior probability of spam. There is no likelihood, guys. I'm asking only prior probability. Prior probability is 28 by 100. Prior probabilities are completed. Prior probabilities. For prior probability, we don't require the internal what words are there also. Just we require the count. For prior probability, we don't require the internal what is there. That is not even required for prior probability. Just open your mail after the class. Just open your mail. Check in your Gmail account. Total how many inbox, total how many mails are available for you in the ham? How many mails are there in the spam? Check. After the class, please check yourself. Whether you may read, you may not read. If you have not read also not a problem, but count will be available now. On the top count will be available, right? For example, if I take myself, okay, just I'm showing in my case. As this is only going to be the important for the Google to classify whether the future mail. So just I'm trying to open because this is the mail ID where I'll get some spam mails also. Okay. Now here my inbox, total my inbox mails consist of how many? 2847. Of course, in that 5 of them are unread, but total is how many? 2847. At the same time, if I open my spam, Total, how many are there in the spam? 214. 214 spam mails are there. 2847 ham mails are there. So for prior probability, what is the prior probability? That is 2847 divided by total. And spam mails are 214 divided by the total. Total number of mails. What is the total number of mails? 2847 plus 214. This is total basically. Now total mails are for me approximately. I'm writing approximately, which is equal to 3061. Okay, the value is equal to 3061. Now, what is the prior probability of mail? In my case, for me it is different. For you it is different. For you, same number will not be there na, in your account. Your account may consist of more number of mails. Your account may consist of less number of mails. So based on what are the mails I have received, from this, it is getting calculated. The probability of ham is equal to prior probability. Prior probability is equal to 2847 divided by 3016. What is meant by prior? What is the advantage of prior? Means my mail mostly consists of ham mails than spam. For example, some people will have 100 ham mails. They may have 300 spam mails. Spam mails will be 300. For them, in their mail account, by default, more number of mails they are going to get in the spam or ham mails. For those people, they are going to get more number of mails in the spam. In my case, which one I am going to get more miss? In my case, priorly, miss more number of mails. Generally, my mail account has the more number of ham mails. That is the advantage of prior probability. Point is clear? Advantage of prior probability. Everyone, understood or not? Okay. Now, so here within my ham, total 717 votes are there. Out of 72 mails, 72 ham mails. In that, how many votes are there? 717 votes are there. In that, each vote, how many times it was counted? It will do this one. In your mail also, in my mail also, whatever we are having the account, in our account, first it will calculate total how many votes are there within the ham. First it will identify the votes. For each word, how many words are there? Each word. For each and every word, it will calculate the count. For example, the count of friend, 86 are there. Count of rich, 41 are there. Count of money, 79 are there. Count of beach, 80 are there. Count of office, 75 are there. Where within the ham. And it will calculate the what is the probability of that each word. And similarly, for the spam, what is the probability of each word? Now, whenever you receive some new word, some new mail, friend, rich, beach, and money. This is the new mail which you have received. Now, what it is going to do is the probability of the new mail, what is the separately we calculate? That is first prior probability and for each word, likelihood. What is the probability of friend within the ham? What is the probability of friend in the ham? 0.23. What is the probability of rich? 0.11. What is the probability of beach? 0.22. What is the probability of money? 0.21. So just it is going to multiply that. Similarly for the spam. Now out of calculating, that is prior probability into the likelihood. This is everything is likelihood. This is prior probability, which is 0.28. 0.72. 0.72. Similarly, probability of spam is 0.28. This is prior. This everything is called as likelihood. So prior probability into likelihood. And after calculating the prior probability into likelihood, which value is the highest? It will be selecting that. In that way, our mail accounts are working. Everyone is clear? And one student, if I send, for example, one mail I have sent, for one of the student, it will go to the ham, that is inbox. For one of the student, it will go to the spam. Why? Why it is going for the inbox for one student, for why it is going to the spam for another student? Why, miss? Reason is very simple. It all depends on the previous mails within your account. In your Gmail account, what are the previous mails are there? In that previous mails, how many times these words are there? Based on that, it will be decided. Okay. Now it is clear, guys, everyone? Yes. Here, as one of the question is, for example, I have created my mail account just now. I have created just now only. Not even one mail is there. Created only now. I have not even received one mail till now. What is the prior probability, miss? No prior probability, na? Inbox is not there, spam is not there, not even one mail is there, not there. Likelihood also not there. Nothing is there. Then how it is going to classify for the new mail? Means the Google will have, okay, some 1,000 records data with them. Initial data they will provide. Okay, so Google has data. What are the Google has the data based on that first 1,000 mails. What are your first 1,000 mails you are having? 1,000 mails or 100 mails, that it will not by the Google, right? Let's take an example. As per the Google data, first 1,000 mails will be classified based on their data. After 1,000 mails are reached in your account, now everything is personalized as per your mail. For example, if you have created one new account, you have created new account, I also have created the new account. We both has created the new account. Now we have we both has got the one new mail. For both of them will get in the inbox, or we both of them will get in the spam commonly. Till how many? First 1,000 mails. Once 1,000 mails are completed, then my data probability will be calculated. Your mails, the data probability will be calculated separately from there onwards. Point is clear? Up to certain extent, they will give the initial support. Is the point is clear, guys? Same way, for example, if you have created your Gmail account, and using that Gmail account, you are opening the YouTube for the first time. First only it will recommend for you the video, na? Just try to create one new one and open in the YouTube. You will not even find the first video also. Empty will be there. If you are interested, try. Not even one video. Now open your YouTube app in your mobile phone, open. Automatically on the starting, you will have the different videos. Now, what are the videos you are having in the YouTube, and my videos, or what are I'm having on the YouTube in the first page? Both will be the same, huh? No. How it is customized? Based on what you have observed earlier and based on what I have observed earlier. In that, which type of videos I have observed earlier, based on that, it is going to recommend for me. That is nothing but again probability calculation only. Of course, the concept is different. Logic will remain same. So whenever we are going to do the personalization, okay, automatically the logic will remain based on the probability. So which one you are more interested, that one it is going to recommend for you more based on your individual. Understood? Done. So we'll continue from here in the tomorrow's class. If anyone has any questions in the Naive-Bayes theorem, please ask. Sure, Girija, I will go through the mail. Okay, till now I have not checked. Let me cross check and I will give the reply. Surely. Yeah, Dilip, I will share this recording. Once I receive the recording tomorrow morning, the moment I receive this one, I'm going to upload in the Google Classroom. Right? And here I can see one more student, Venugopala. 1 minute. Yeah, Venugopal only. So the likelihood of the friend is showing the different value. As an example, guys, maybe here mistake is there. Generally, the probability of friend, what are the probability of friend is there? We calculated as 0.23. Na? Here it should be 0.23. Right? What are the calculation is there? Just maybe the numbers change. Nothing difference. Okay. As an example, just we have kept like that. Yeah. Now I'm going to share you the PPT. This snap Bayes theorem notes, whatever is there. Just I'm going to share you the PPT. And now if you understand, okay, it is purely working on the individual boards. For example, SRK data trainer. Trainer data SRK also answer is same only. Here the order of the words is not important for us for test classification project. Is the point is clear, everyone? How many times SRK is there in the inbox on it will check, but in which order SRK has came, it will not check. So here order of the words is not important. Right? Done. If no questions, you can leave. I will share you the recording by morning. Once I receive the recording, immediately I will share.